day for parabolas. Tomorrow I'll tell you about the test I put Micah through last night. It was great. What? Okay, so parabolas, here we go. What is a parabola? Parabola is the set of all points whose distance is from a focus point and the directrix line is the same. That's my shorthanded definition. Set of all points whose distances from a focus point and the directrix line is the same. So what does that mean? Let's draw it out, okay? If you didn't get it all down right now, it's fine. You can get it down in a second. A parabola has a spot on the inside, and we call that the focus point. It has a line on the outside that we call the directrix. And the interesting thing about the parabola is the distance from the points. So that distance to the focus is the same as the distance to the directrix. Now, I maybe didn't draw that very well, but the length of both of those green segments are supposed to be the same. Supposed to be the same. And technically, that's how you would generate it. Now, we know that if you took a cone and you sliced it diagonally, that you would come up with a parabola. That's that. Okay, let's talk about the equation. So the equation, I'm going to write two of them. You could either have y equals ax squared, or if you transform it horizontally and vertically, it would be y equals a times the quantity x minus h, quantity squared, plus k. That look familiar? I'm sure it does. You've learned it before. Now, horizontal would be x equals. So you could graph horizontal parabolas, which we end up using in calculus in fourth quarter. It's really exciting. Y equals a times y squared, and we get, or x equals a times y minus k quantity squared plus h. Took an allergy pill this morning. I've been making a lot of mistakes at the board. My mind gets a little quick for me to catch up. No, don't need to know definition. In fact, we're almost done with this stuff. You're in test next week. Axis of symmetry. Let's talk about the vertex first. What do you think the vertex is? What is it for that one? 0, 0. What is it for this one? Very good. Same thing for the other, 0, 0, and HK. The axis of symmetry divides the parabola in half, so it's symmetrical on both sides. So if it's a vertical parabola, will the axis of symmetry run up and down or left to right? Up and down. So it's a vertical line, yes? So it's an x equals line. If it's x equals, it passes through the x value of the vertex. What's the x value of the vertex? Yeah, 0, or in this case, if we transform to h, I'm not going to write 0, 1 down. You guys got the idea now. How about if it was a horizontal parabola? The axis of symmetry would run side to side, right? And lines that run side to side have y equals, and therefore it'd have to pass through the y value of the vertex, which would be k. Super duper. The focus is that point that sets on the inside of the parabola. That's a really, really poor definition, but sits on the inside. And it is p units from the vertex. The directrix sits on the outside. Guess how far it is from the vertex? Yes, you're so smart. So what is it you want me to tell you now? How to find P. A equals 1 over 4P. We use that. You take A, which is the lead coefficient, set equal to 1 over 4P, cross multiply, solve for P. We'll practice it all. We'll be really good at it. Direction of opening, if it's vertical, then it needs to open either up or down. So if A is positive, it opens up. If A is negative, it opens down. If it's horizontal and A is positive, it opens to the right. If A is negative, it opens to the left. Now we're going to get this word out of the way. It's a very awkward phrase. Lattice rectum. Last year we said it, and Jacob Kunkel took too much enjoyment out of the word. In fact, he repeated it probably 15 times in class, rather loudly. So we all need to get over our fear. Lattice rectum, okay? So let's just say the word together. Ready? Lattice rectum. Okay, all right, you're not afraid of it. Okay. Right. It's like we're doctors and we're talking about things that you seem like you shouldn't. Okay, length of lattice rectum. Length is equal to 4P. Now you're wondering, what is the lattice rectum? The lattice rectum is this black segment right here. And it runs through the focus, and its endpoints are on the parabola. And it's a really quick, easy way that we can figure out how to sketch this and get a really accurate graph of it. So that's kind of cool. Okay, so what if it went sideways? What if we had a horizontal parabola? Make it go like that. Let's label the points just so we can practice. What is this spot called right here? Vertex. What's the point that sits on the inside called? Focus. How many units is it from the vertex? P. What is the line that sits on the outside? Directrix. What is this segment called right here? Lattice rectum. How long is the lattice rectum? 4P. That's it. This cake. Upside down. You're so smart. Let's do it. All the characteristics of the graph. What's the direction? Up or down? Left or right? Is this horizontal or vertical? How do you know? How are you so positive that this is a vertical one? Because it's solved for y. It's y equals, and because it's positive, it goes up. Good. Direction is up. Vertex. -2, 3. I start with there and then I find P. Let's just find P right now, okay? In order to find P, I take A. What is your A value? 1 over 8, and you say equal to 1 over 4P. Any idea what P is? Dos! If you can't see that, cross multiply and solve. P is 2. I'm going to start sketching before I write everything else down. So, all right, I need a shape here. Let's see. -2, +3. Go like this. Okay. All right, so I'm going to plot the vertex. So as opposed to trying to figure everything out, I'm going to draw it out and then write it down. Okay, the vertex was easy. -2, +3. Got it. Perfect. So the axis of symmetry is going to run right through that. What is then the equation for the axis of symmetry? X equals -2. Focus point. How many units do I go to the inside of the vertex? P units, 2. So I'm going to go to the inside of the vertex. So I go up 2 units. What's the location of that? -2, +5. Good. Directrix, I go 2 units on the outside. 2 units on the outside would be down. So if I go down 2 units, I draw this horizontal line. What's that equation? Y equals 1. Length of lattice rectum. What's the length? 4P. What's P? 2. 4 times 2? 8. So if it's 8 units long, how many units do I go to each side of the focus? 4. So I'm going to go 4 to this side. And I'm going to go 4 to the other side. That's my lattice rectum. And my graph will pass through the endpoints of that lattice rectum. I can now sketch the graph. And it gives me a really nice shape. And that's more than you ever thought you know about a parabola. I used to teach the parabolas first. In fact, this is section 9.1. However, every time I teach it, everybody says parabolas are the most confusing part. Every single time. And so I've started teaching ellipses and circles first, and then hyperbolas, and then parabolas last. You think that they're easy. What's easy for you isn't easy for everybody. All right. Okay. All right, let's flip to the other side. I don't want to do that one. I want to do this one. 2x equals y squared. What do you think? Divide by 2. Good. X equals 1 over 2 y squared. Graph it. List all the important characteristics. We start with the direction. What? Right. Why? X equals, so it's horizontal. Positive opens to the right. Very good. Vertex 0, 0. I'm going to figure out P right now. In order to figure out P, I take A, which is 1 over 2, and set it equal to 1 over 4P. Good, 1/2. If you cross multiply, you get 4P is equal to 2. Divide by 4, P is 1/2. Good, I can start sketching a graph here. Vertex is 0, 0. I plot it. P is 1/2. So the focus goes 1/2 to the left, right, up, or down. Right. Goes in the direction that the graph goes. So I can now write the equation for the focus. Or I'm sorry, what's the focus point? 1/2, 0. Axis of symmetry divides it all in half, right? What's that equation for the axis of symmetry? X equals 0. Whoop, Y equals 0. Sorry. Directrix. For the directrix, I go 1/2 a unit outside, so that'll be to the left. And I draw my dotted line. What's the equation for the directrix? X equals -1/2. What's the length of the lattice rectum? 2. So that means I go how many units in each direction from the focus? 1 unit in each direction. 1 unit this way. 1 unit this way. So that black line will be my segment. And the red is the shape. Beautiful. What up, dog? What? Directrix. The directrix. So you see how the focus point is 1/2 a unit on the inside? The directrix is a 1/2 a unit on the outside. And it's a line that runs perpendicular to the axis of symmetry. Got it? Any other questions? No? It's too easy? Second hour is going nuts. They're freaking out. They're ready to throw stuff at me. Okay, well, we're ahead of schedule. So let's do the last one. We're skipping that other one. But we got to change the equation because I don't like this one. Actually, I changed it when I wrote it, but I must not have pressed save. I mean, I remember thinking that exact same thing. I was like, I can't have a 1 there. It's ridiculous. Who would write a 1 there? Okay, what do you want to solve for? You want to solve for X or Y? X, very good, because Y has a squared on it. You don't want to solve for the Y. We solve for the X, we subtract 24. We get 12X equals Y minus 2, quantity squared, minus 24. Now what? X equals 1/12 times Y minus 2, quantity squared, minus dos. Direction, up or down, right or left? Right. It's an x equals, so it's horizontal. It's positive, so it's to the right. Vertex. Close, no cigar. Oh yeah, no, I'm sorry, you're right. Negative 2, 2. Why isn't it 2, negative 2? Because the y coordinate is 2. The x coordinate is negative 2. It switches when it's x. See? The y is attached to this, so. That's a smart guy, that Cody back there. He's been paying attention the entire hour, and he is ready to roll. Let's just have him come up here and teach. Okay, so we've got that. We need the p-value. Anybody know what p is? 1 over 12 equals 1 over 4p. Cross multiply, solve. P is 3. Let's draw a picture. Some would call it a graph. Let's see, negative 2, positive 2. Oh boy. Okay. Okay. Let's plot our vertex. Vertex goes at negative 2, positive 2. So what's the equation for the axis of symmetry? Very good, Haley. Y equals 2. Focus goes how many units from the vertex? How many? 3, because P is 3. 3 to the right, left, up, down. Right? What's the location of that point? Directrix, how many units? In the opposite direction. 1, 2, 3. Vertical line. Equation x equals or y equals? What? Negative 5. It's the length of the last rectum. Very good. How many units in each direction? 6. Wow, so all the way down here at negative 4. All the way up here at positive 8. Use my handy dandy segment creator. Draw my graph through the endpoints. There's my shape. Isn't that cool? And you wonder when you're ever going to use that. You tell me. Anybody got a satellite dish on top of their house? Yeah. What shape do you think that makes? It's a parabola. It's a parabola. It's even got that center thing in the middle. Or whatever. You guys have no idea what you're talking about. Go watch your MTV. All right, so here's so what are we doing the rest of the way? So we've now covered everything. All you got to do now is we got to give you equations that look like this. You got to be able to transform them into the appropriate shape and understand if they're parabolas, hyperbolas, or ellipses. Double complete the square time. Yes, very good. Anybody know what shape that is? It's an ellipse. They're both positive, and these are different. So there's some easy ways to tell, and then we got to complete the square divide. It's really not that bad. That's all we have left to do. And so you'll actually have a couple days of work on your study guide and homework and stuff, and you'll actually have a couple days to practice this. So I would like to, on Wednesday and Thursday, do this stuff. Friday, you can have the whole day to work on whatever you want. All of the study guide ready. We can test next week, Tuesday. You're all caught up with your homework. You guys are caught up yesterday. Here's your assignment. I try to make the assignment short. 1 through 6 are matching. You just got to pair it up. Then I have 3 problems where the vertex is at 0, 0. And the rest of the stuff, just do exactly what we did in class. List all the stuff that we did. And then for page 760, there's 2 where they're shifted. Just practice that. And that'll be fine. So that's not too much. In fact, you could probably get the matching done right now. Then you just have the 5 graphing. And that'll be that. It'd be worse. You could have calculus as assignment. They weren't done with their assignment from before. Well, Kelly was because she's a good student. But I dumped another one on them today. And they're going to get another one tomorrow. Don't tell them. Gotta keep the feet to the fire, people. We can always let up in May, right? All right, there you go. Good luck.